My name is Alexander Sokol, and this is day one of the course on enterprise software development in Python, presented by CompatibL. So first topic is version control. First of all, the appropriate version control practices are critical to producing reliable and mostly bug-free enterprise software. Without version control, the enterprise project will fail. And by enterprise project, I mean, any large-scale project that should be mostly bug-free, right? No software is completely bug-free, at least not that I know of. But it should be mostly bug-free. It should, when the bugs are found, it should be easy to fix. When you're doing features and you fix a bug in the older version, it should be possible to merge the bug fix into the latest version. So you need to have appropriate version control practices, right? So not just the right software, but also the right way of using the software. And back in the ancient times, think about ancient Greece or the Rome, when people were basically wearing togas, right? So there are these ancient version control systems such as CVS and SVN, which were collectively called Centralized Version Control Systems, CVCS, right? So these things are so old that I think the younger generation, people who are students right now or students recently probably never even heard of them. But I want to mention what they did because, this just shows what the critical innovation was in distributed version control, which is what is the prevalent version control approach today. So it's more clear, right? So the history in a centralized version control system is stored in a centralized server. And developers put a snapshot of the computers, but not the history, right? So if you're a developer, the history is on the server. On your computer, you don't have the history. And developers can create branches, right? But eventually must have merged the branches to the centralized branch of the trunk. And when they do development, they do not have the ability, so rather the version control system does not have the ability of seeing the sequence of changes, right? So in other words, all version control system knows is that you pull the certain version of the code, and then you're trying to merge it back to the shared repository later. And with CVS, anybody who is like me old enough to remember, right, there was a lot of screaming around the development office, well, don't merge yet, you're going to break my code, I will merge first. So essentially, there was no really good way to resolve conflicts. In fact, the systems actually did have the ability, from a formal perspective, right, there was a function called merge, but it worked very, very badly and you couldn't trust it. And the reason is that the version control system had no idea what sequence of changes happened with the code, right? All it knew is that two people checked out the code, checked out, copy it in the local computer, right? And then, they're trying to merge two different things and it's not clear how to put them together, right? So Humpty Dumpty fell off a wall and, all of the king's horses don't know or something like that, right? So now distributed version control systems or DVCS, right? And the first one was actually a commercial system, which was Perforce, was based on the revolutionary idea that each developer should have complete history on their computer. And Perforce was a commercial system and was eventually followed by open source system Mercurial and Git. For the reasons that I don't want to get too much distracted from my topic, right? So we'll not talk about this further. I don't say that Git is the de facto standard of version control today, right? Not Mercurial. So Git 1, everybody uses Git, right? So don't, and if you learn any other version control system, your boss will send you to work on legacy project written in COBOL. So my recommendation is not to. All right, so Git, the last bit of trivia, right, is that it's the second most popular open source project by Linus Torvalds. And of course, he's the creator of Linux. And Linus Torvalds said that the names of all his open source projects after himself, right? So in Git, it's a slang, right? So unpleasant or contemptible person. So, well, I humbly disagree, but, that's what he decided to call it. All right, so hands-on session on Git, right? So during the session, we'll learn the key functions of the front-end tools for Git, right? And I strongly recommend not to use Git command line interface, even if you know how to use it, and use it for complex situations. Because instead of famous for your command line skills, you will become famous for merge errors. Like you can literally make absolutely horrendous merge errors, commit files you don't want, commit files you don't want, and so forth, if you don't use a front-end tool, right? We'll show how to initialize and clone a Git repo, required files, what to put in the commit message. These are all basics, right? I'm sure most of you know that, but we'll just rehash quickly, right? And then more interesting stuff, right? Commit strategies to reduce merge errors, merge types, right? Rebase, merge commit, cherry pick, and when to use each. something called git flow, which is a way to manage branches. That's one way. And the other one is called trunk-based development. So we'll talk about that. Merge conflict resolution, and oh yeah, they already mentioned branching strategy. So with that, let's go to the hands-on session. And what I will do is I'll switch to PyCharm, and hopefully we'll be able to proceed from there. 1 second. Actually, what I need right now is a tool, right? Okay, so first of all, the tools, right? So there are a few tools for version control, and I will have on my screen one of them right now. So let me just.
Alexander, you're not sharing PyCharm.
Yeah, I understand, right? So I'm about to share, right? Just 1 moment. Okay, so I think what I'll do right now is just share the entire screen because there are 2 separate windows. 1 second. Okay, so with that, you should be able to see the entire screen, and I will minimize the Skype chat. I see that a lot of messages in the chat. Anastasia, are these messages related to any
all
questions
under control, no worries.
Okay, sounds good, right? Okay, great. Yeah, so let me just maximize the screen, and please confirm: is the Zoom window blocking the screen for you right now, or it's not?
It's not. It's not.
It's not. Okay, great, right? So I'll just move it out of the way, but it looks like it's not blocking anything for you. Right, okay, so first of all, you can clone the Git repo and you can create the Git repo, right? And one thing, just very quick thing I want to say about creating the Git repo. And again, this is probably doesn't matter, you wouldn't even notice this issue if you're working on a small project, but for a large project, it can become a problem. Is that when you create the file, there are several very important, when you create the Git repo, there are several very important files there that absolutely have to exist, right? And there is an important way in which you need to put one of the files into the very first commit, right? So this is the Git repo, right? .git file is where Git stores its database. So, you don't need to use it, and you should exclude it, of course, from any searches and so forth of your development environment. Okay, then the source folder is where the source is. We'll go there in a second. And there are 4 files here, right? Git attributes, git ignore, license, and readme. And normally everybody starts from git ignore, but actually it's git attributes is the most important file. In this file, I will open it. All it does for me right now, it says that it's automatic detection of text. Okay, so essentially what it's saying is that it relies on Git to automatically detect if the file is a text file, because text files in version control, they're different, right? So first of all, if you check them out on your, for example, Windows development environment, you have to use Windows line end. If you check them out on your Linux machine or for the cloud, which is Linux-based, then you need to have different line ends. Also, when you're merging, it will expect that there will be diffs that it will analyze and merge for text files, but not for binary files. And what happens is that if you don't have Git attributes, it may, right? It may incorrectly assume that some files are binary when they're not. For example, if your text file has some unprintable character, like for example, if you have UTF encoding, or if you have non-UTF, apologies, if you have non-UTF encoding, right? Sometimes complex encodings, foreign languages, namely languages other than English, cause the file to be seen as binary, or vice versa. You have the file that appears to be text, but actually should not be subject to merge. So one way is to put in Git attributes, and you can look it up very easily in the reference. You can put specific file types that it should treat as text or as binary. I just put auto, and it's a heuristic detection. Okay, so that file should be in the first commit, right? And when you create a repo, and I'll show how to do it in a moment, you need to amend the first commit in order to put this file there. Because if that is not done, then, if it's a second commit, it's probably not the end of the world, right? But generally, if there are pieces of, for example, if there are 2 repositories, and you're merging them together to create a merged repository, that's called the orphan branch merge. If one of them has one Git attributes and the other one has a different Git attributes, Git will take basically 10 minutes instead of a few seconds to merge. every time you're doing a commit, because you'll be checking the line-ins, and that's very undesirable. All right, so git attributes is the file that again, it's very simple, but it's very important, right? So now second file is git ignore, right? So that file prevents you from accidentally committing the files that you don't want, things like generated files, temporary files, and so forth. And also from seeing these files when you're trying to make sure that you're current and you update it. So git ignore is where you specify that. You should always put the license in the root, and this is Apache license, right? So people basically will look at the root and look at the license. And also when you go on Git, right? So if you go on Git, actually I should have opened it in advance, but let's see. Let's hope I don't have to go through the whole authentication here. So let's see. Okay, yeah, good. We're already authenticated, right? So what will happen is, you see Git here says Apache 2.0 license. So most of the tools will actually read this file and determine that what kind of license is in there. Right. So second and last file is README, right? So you see, and this is the same for GitHub, for enterprise GitHub, which is professional development environment, and also for Bitbucket, which is another even more popular professional Git server. So basically, the two leading ones are, GitHub. Sorry, actually, correction, right? So there's GitHub, there's GitLab, there's Bitbucket, right? So all of them do two things. First of all, they show you license from this license file in here, and second is they show the README file here. And if your README is not a TXT file, or if it's not a file with no extension or TXT extension, if you use MD extension, which means Markdown, then you can actually format it. This is a very short sample file. Normally, in a good open source or commercial project, you'll have, sometimes for some packages of limited scope, you can put the entire documentation here, but at least should be very, very detailed summary with links to everything else, right? So these are the key things that you expect in the Git repository, right? And in order to just coming back here, so in order to avoid these problems with Git having difficulties merging, when you create a repository, it creates the initial commit for you. You need to amend this, the best way is to amend this commit to add git ignore and git attributes. If you don't do that, that should be the second commit, right? So let's just, given that we only have 1 hour, I'll probably just skip that part because I already talked through it. Right, okay, so now let me go back to SmartGit now. Right, okay, so SmartGit is one of several Git front ends that you can work with. And there are several key things that they do, right? So first of all, they let you push code to Git and get it back, create branches and delete branches. But the most important component of it is the diff, right? So you will be able to see the difference between two branches, two versions, and so forth. And in order to demonstrate, how this works, let's work together on a poem. Right, so I promise at the end we're going to come up with this amazing poem by Robert Frost called it's not called The Roadless Traveler. I think it's called The Road Taken, right? But we're going here to let me see the name. Yeah, okay, The Road Not Taken. That's what it is, right? So that's the famous phrase. They'll take the road less traveled. Is from this poem, right? So imagine that that we decided to create this poem, right? But let me first let's make the assumption that there are two people working on this poem, and let's call them Jack and John. Right? So developer Jack and developer John are together working on a poem. Okay, so now we have 3 files here. So I'm just going to, I just saved them because I want to have snippets, right? So one of them just comes up with a title and comments, right? Okay. commit message, right? So, and by the way, there are a few things here with the commit message, right? So when using issue tracking system, you will be able to put the tag of the issue tracking system here, both for Git and for Bitbucket, which then connects to Jira. And for Git, you can connect to Jira or to Git tracking, and that is something that we will talk toward the end when, basically in section working as a team. So for now, we just say, I came up with a title, right? So, but there should always be a commit message, right? In fact, it's a good idea to set up a hook for the project, so empty commit messages are not allowed. Okay, so now we have you came up with a title, right? So we're looking at log, come up with a title, right? And then one of the engineers come up with the first verse. And then the second engineer, and I'm going to pretend I'm the second engineer by creating a branch. And the second engineer now goes and adds the second verse. I'm sorry, did I add the verse? Yeah. Okay, and now I'm going to pretend again that I'm the first engineer, right? And 1 second, so let me just push the branch. So now I still have the first verse. I'm going to work on it and say, long I stood, say for a very long time, I stood. I'm going to improve on the poetry because I think it just sounds a lot better this way. Right? And I'm going to commit that. Just bear with me, I'm almost done setting it up, and then I'll talk about merging. Right? Improved upon Robert Frost. Hey, who says I can't, right? All right, so now we're going to push. Okay, so now the thing is, on the branch, I still have the second verse and the original version of the first verse, right? And then it looks like this, right? So I have the branch and I have two commits, right? And there are three ways to merge these commits, right? And this seems simple, right? Because I'm just using two verses and one piece of poetry, right? But the way that merges are organized actually is critical to the success of the project. And there are three different ways of doing it. And each three of these ways, even on a single project, there are some appropriate situations where you use one versus the other. Sometimes on a project, there is a preferred way, for example, trunk-based development of Git flow, right? And there are basically any deviations from that are not recommended. But my preference normally is to base it on the following, right? So there are three ways to merge, right? And this is the reason I set up this poem. Right, there are three ways to merge, right? So one way to merge is to rebase. Okay, so when you rebase, you take the commit that you have and put it on top of somebody else's commit, right? So in other words, you pretend that your changes to the verse were happening after somebody else did all of these changes. That's rebase. And the issue with that is that, so the advantage of that is that it creates linear history, right? After you're done with rebase, you can delete your branch and as though the branch never existed, right? So as though it looked like two people who worked at the same time, it looks as though they worked in sequence, right? And people, of course, in the development team cannot work in sequence because the project will take forever, right? So, so that creates the illusion of working in a sequence when actually we didn't. Okay, so the disadvantage of that is that if you on your branch, created the working code, and you tested it, you will, after you delete your original branch, not be able to figure out exactly, how to reproduce the results, right? So because essentially you tested your code, but your code that you have works in a certain way on top of the previous version of the code. Now you took your, Nessa, do you see my video, even though I'm sharing the screen?
Yes, sure.
Okay, right. So now you took your changes, right? And you apply them on top of somebody else's changes. But on top of somebody else's changes, your code may not work the same way as it worked on top of what you started from. So if you already tested, essentially your version that was tested and worked is gone, right? So well, gone after you delete the original branch, or it's on some side branch that's not really, part of the development. So you will not be able to determine, like, did it really work? Was it broken when you rebased? Or was it actually never working to start with, right? So that's one of the disadvantages of rebase. The advantage is that history is linear and the branch, beautiful, branch never exists. Okay, so other ways to do a merge commit, right? So I'm going to show a merge commit in a second, right? So with a merge commit, you will preserve the original code based on what it started from with the test, right? And you will preserve the first set of changes on the develop branch. Well, in a lot of workflow practices, you don't want to do it on develop, right? You want to basically have two branches and then merge both on develop. But it doesn't matter. We're just talking about two branches. So the advantage of that, you preserve your tested code on one branch, tested code on the other branch. When you merge, then you have the merge branch, right? And then you can say, well, the first test worked still good, right? Second test worked still good, right? So this, you have both previous ones and a new one. But if you ever have to undo something, right, you have to undo. Then it becomes very messy because you have essentially branches that diverge and merge together like a river, right, around the island. And if the commit that's causing a problem that you're trying to undo is earlier, then there's not a single obvious way of how to undo it properly because you don't have a linear history. You cannot just say, well, take out this commit, leave the rest, right, or even go back to a single set of code, right? So that's a disadvantage. Okay, and the final third way is cherry pick, right? Where you go from branch one commit by another commit and cherry pick, basically cherry pick means that you're taking these commits one by one. So cherry pick is really, normally the same thing. Sometimes it's considered the same thing as rebase because rebase is just a sequence of cherry picks all done at once. Okay, so now, I'm not, of course, reading from a Bible here. So, every manager, every development organization has its own set of preferred practices. And, I'm saying what I believe are the right practices. So I believe that the right practices are when you already tested, you should merge, right? So there is a merge commit because then you're preserving what you already tested. And when you did not yet test your new code and you would like to test it together with on the main branch, then you can either rebase or cherry pick, right? So now that we committed both branches, let's see how it works, right? So let's try first to merge, right? So I'm going to go to develop. So I'm going to check out develop, right? So when I check out this branch, I pretend to be the first developer. When I check out this branch, I prefer to be the second, right? So now I'm trying to merge, right? And either of them can do it, right? And note that each of the developer has a complete history on their computer, right? So I'm going to go and merge the branch. And you can do two ways, right? So you can do merge commit. If you're really feeling, as Google says, you're feeling lucky today, right? Do merge commit, otherwise merge to working tree. But if anything goes wrong, it will basically, fall back to the tree, right? So, okay, well, I was feeling lucky. It did the commit. And as you can see what happened here on your right, right? So for a very long time I stood, right? So my improvement upon Robert Frost was accepted by the merge. And also there is a second verse, right? So that's how it worked. I can push it here, right? Okay, so now we have one change, another change, and a merge. Okay, now second thing is I'm going to go back, right, and undo this commit, right? So I'm going to, and by the way, there's a very nice function here. And by the way, so I went kind of very fast again because of the time. This is Smart Git. I like it. I think it's a really good tool. It's not the only tool, right? So any other tool, for example, another tool that I have here is SourceTree, right? So that's another tool. It's actually SmartGit is actually a commercial tool, right? So it's only free for open source development. So I have a commercial license, but it costs money. If you work on open source, it's free for you. And also there is a source tree, which is always free. There's Git extensions, and also in PyCharm, there's a built-in version control. So it does not matter which tool you use. But what's important is that this is a tool that has a visual diff, right? And this visual diff here, as you can see, it shows exactly what was done. So I started from already corrected first verse, and now the merge added this one. Okay, so now the other way of doing it, right? And in order to do that, I'm going to undo this previous commit, undo last commit. Okay, so I'm going to undo last commit, and I'm going to reset the. Okay, second push. Okay, so force push, I'm going to just override this previous commit, right? Okay, so now we're back to where we started, right? So what you can do is you can do either rebase or cherry pick. So I'm going to cherry pick. So rebase is just sequence of cherry picks happening automatically in sequence. So I'm going to cherry pick, and what it will do is it will tell me, okay, so let's take this change and apply it on top of the original branch. So this time, instead of cherry pick and commit, I will go cherry pick, and note I click this append SHR to commit message, and this actually is called differently in source tree. But what this does is it lets you actually recover the original version even after the change, right? So let me just show how it's done. Right, so now cherry pick succeeded, and now we have the modified verse again. So as you can see here, it applied the second verse and merged it with my change to the first verse, right? I'm going to commit. And you see, it says cherry picked, right? So let's just remember, this. I'm just to copy this tag, right? So second verse on branch, right? So okay, so now the way it looks like this, right? Now we have the branch. So this branch ended, right? I'm not working on it anymore. There is this change in the second change, but the second change in the commit message has this link, this hyperlink, right? And if I click on it, it will point to this place where it came from. And now you have two options, right? So one is to retire the branch, but keep it, right? So there could be a naming convention for the branches that you don't use. You can keep it for some time, or you can delete it, right? So if you delete it, so I'm going to go and delete the branch, I will end up with linear history. And I'm going to delete it even from remote repository, otherwise it come back next time I pull. Okay, so now we have our improved quote unquote poem in a linear history, right? So now if I'm going to undo anything here or come back to every previous point, I don't have to worry about like which of these two branches works. All right, so that concludes the version control hands-on exercise. And at this point, I would like to ask for questions. Anastasia, any questions I should answer right now before we continue?
There is one regarding the software.
Okay, 1 second. Just open. It's on the bottom, right?
It's in our internal chat.
What's the advantage of alt-rated software? It's just data. Like I'm not recommending it. It's commercial. Also, it's pretty outdated. I'm just used to it. I mean, use Notepad++. Okay, PyCharm. Yes. Sorry, you don't see PyCharm because I was using alt-rated again. So I like alt-rated. I would not be recommending it if it was purely commercial, but it's free for open source. It's not a. I can guarantee that alt-rated is not paying us for this. It's just, it's basically, I didn't want to spend minutes trying to figure out how to do the same thing in source tree. So it's another editor I know, but alt-rated I just use all the time. Source tree I would have to figure out how to do things, and this will take like extra minutes away from the course. All right, so Nastya, what is the question that I should answer?
Could you please check our chat?
Okay, 1 second. Don't see anything there. Oh, actually, I do see it. Yeah. What advantage to result? Yeah, so that already. Okay. So where's that SHA we added to the community? Okay, so I'll try it. I already answered again. I promise you, these guys are not paying us, and they seem to be a really low key. I don't think they have advertising budget either. It's very small group again. So I don't recommend alt-rated unless you're already used to it. That's the only reason I use it. Yeah. So right. So Okay, now where the char we added to the commit is pointing to now that the branch is deleted. Okay, so it's pointing to here, recyclable commits. That's actually an excellent question, right? Okay, so what Git does, right? One of the things, by the way, that I didn't want to spend a lot of time on, but the reason Mercurial lost to Git, right? And Mercurial actually has some tremendous companies supporting them, like Facebook, Meta, right? Now called Meta. So Mercurial was actually something that Zuckerberg selected for Facebook, right? And it had a lot of momentum. The problem is that in Mercurial, you cannot actually never delete an erroneous commit, right? So in Mercurial, once you have a commit, and you can only delete basically the last commit. Once you have a commit and you kind of like branch, right? And you started, with Mercurial, you can never actually delete anything. Right, and also if you have the wrong commit, you can literally have to like wipe out everybody's computers from that wrong commit if you just don't want it at all, right? Like for example, you accidentally committed a giant file, because any developer who had that commit on their computer during the sync, it would come back. And this was absolutely ridiculous behavior that I wish Mercurial developers didn't implement. So Git, what it does is that when you delete something, it also stores it, because sometimes you delete the wrong thing, right? So for a second, I pause here just to make sure I'm not deleting the entire develop branch instead of this branch that we created. But it stores for 30 days whatever you deleted on your computer, in case you slap your forehead and say, wait a second, like I deleted this accidentally. So you see, I deleted it when I click recyclable commits. And I was, recycling truck picked them up, and they're sitting in the truck, but you can still find them, right? So if if the password to your crypto wallet was on that branch, you have 30 days to recover it, and you wouldn't have to search for your laptop in the dump, right? So you see that this branch is still here, right? And you see what basically these commits, they disappear, right? So we have linear history until we click on that. Right. Furthermore, and this actually depends. Let me just see if we'll find it. Yeah. So you see what it did? It's actually interesting, right? So when I clicked on it, it added this, but you can see that there's like a solid line here, and there's a very faint line. So it even found it without checking recyclable commits. So that's why when you're doing cherry pick or rebase, it's very important to actually do this, because then you can see exactly, right? And if you have some doubts about where this commit came from or what was doing, where it was before, that's actually how you find out. Okay, so very good question, right? PyCharm is worse than SmartGit. Okay, so first of all, I was only using UltraEdit for poetry, and I'm only using SmartGit because I'm used to it. And any presenter would just choose the tools that they like, just because you don't want the presenter to basically trying to navigate around an unfamiliar tool and spend your valuable time. So PyCharm, I think, is just as good as SmartGit. I think that in SmartGit, one thing, and generally in the Git tool, let me just do that again, and I want to advertise something, right? So it's very important to have really good merge conflict resolver, right? There's like this very beautiful, clear visual representation of what changed, right? So that's actually the critical thing, because all of the Git tools, right, they use Git for actual commits, branches, and so forth, right? So really the diff tool is the key thing, and sometimes it's an external diff tool. But no, PyCharm is just as good as UltraEdit. Again, I don't want you come away thinking that enterprise software only requires UltraEdit. In fact, it's not even the most popular standard tool, right? So use PyCharm built in, right? Source tree, Git extensions, all of them are great. All right. So now so basically you can do it directly in PyCharm. Sorry, in PyCharm, and in fact I can show you how. 1 second. So this is PyCharm. And this is the 1 second, where is it? Git, right? So here's the Git, right? So you can see here there is 1 second. Oh, you know what? I think okay, yeah. So I wouldn't be able to show it in PyCharm. Yeah, so you see that's the PyCharm. We don't see the poetry here because that's pointed to a different checkout of the same repos, and I don't want to spend time switching back and forth. But PyCharm has the same thing here, right? But any of them are good. So again, so this is, again, we're not recommending any tool. Everybody has their own preferences. They're all good, right? We're just telling you like what tools should have, what features they should have. If you ever come across a front-end tool that does not have a good diff, don't use the tool, right? But among the tools that do, use any that you like. Right. So recyclable commits is feature of Git itself. Yes. So no, it's not a smart Git feature. So this is a feature of Git itself, which Linus Torvalds, in his great wisdom, seriously, I mean, it's a very wise thing to do, added, right? Because it was clearly a mistake to completely lose them forever immediately, because like I myself deleted the wrong commit many, many times. It also would be a mistake to keep them forever, because basically what happens is sooner or later somebody will commit like a gigabyte binary file with data by mistake, right? And you need to be able to get rid of it. So I think keeping it for 30 days is a perfect solution. So it's a feature of Git itself, not of the front end. What additional functionality does PyCharm Professional has compared to PyCharm Community? Okay, so yeah, so the community does have the Git manager. Basically, again, so you've noticed I'm using Professional. It's I don't even know. I don't even remember what the. I think it has to do something with posting your machine learning code to the cloud, right, from the tool. But I don't remember why I got it, frankly. But basically, community for everything in the course, community is perfectly fine for that industry. So I don't even remember why I got Professional. There was a reason, but it had nothing to do with like basic Python things. Okay, right. So and generally, PyCharm developers, right, JetBrains, they're producing amazing software, and most of it's free for open source or completely, right? Just even if you work on commercial. All right, so okay, so we really need to move on, because we didn't get to as far as I had hoped, right? But we still have 3 days to go, and overall, I think that we're moving at the right pace. So let me continue, and with that, again, let me go back to the slides. Right. So now Python environment, right? So first of all. You likely will work on multiple Python projects at the same time, right? And each of these projects will require a set of third-party Python packages. To achieve a stable and reproducible regression test results, the project will require specific versions of these packages, right? And before upgrading a third-party package, its new version must be tested to confirm all regression tests pass. So you need a virtualized Python environment, which is a sandbox, right? So third-party packages installed into that sandbox do not affect, actually there's a typo here, do not affect other sandboxes. Popular options for virtualized Python environments, right? So if you go to PyCharm, it will tell you can do venv, you can do conda, and you can do a bunch of others. Well, these are really the two leading, so don't bother learning others, at least at this point in time. So venv is a lightweight environment manager for Python, requires a separate package manager, which is actually built into Python. It is recommended when you only need to virtualize Python. Right, so this is sort of like I don't know, containers for Linux, where it's a very lightweight piece of code. It shares basically it just provides packages as an extension on top of a standard Python installation on your machine, right? And conda, which is the second option, is both package and environment manager, right? So in other words, with venv there is a separate tool and a separate environment manager. So conda actually has its own version of both, and only in my opinion, right? Even though sometimes people like conda, also sometimes, for example, there are a lot of organizations in which you only have conda or only have venv, right? So you don't have a choice. But if you do have a choice, conda is great because it's not specific to Python, right? So for example, if you write C++, as many engineers who work on math, on finance, you have to write C++ code that you invoke from Python. And if you need to version not only Python libraries, but also C++ libraries, conda is better because you do it all together and you don't have to use Conan. So there's something called Conan, which you can work in parallel with venv, right? But conda has both of them in the same package. And your virtualized environment for both of them is based on a specific version of Python. And we recommend to stay one version behind the latest established stable release. For example, right now, the stable release, latest stable release is 3.10. I'm using 3.9 because there are a lot of third-party libraries that take time to upgrade and certify the latest Python version. For example, machine learning libraries, math libraries, there's some answers change a little bit. They want to verify why. So my recommendation is to always stay one version behind, unless you've been waiting for 5 years for some wonderful Python feature that they just released, and then you have to go there. I see that there are additional questions in chat coming back to the environments. I'm just afraid if I keep answering them, then we will not be able to finish as we planned. In fact, we're already running a bit late. So, I'm happy to stay after the end of the lecture to answer these questions, but right now I'll just continue. All right, so now the role of package manager, right, is, programming language becomes popular not only because of its syntax, right? And the package manager is what you use to load third-party packages into your virtualized environment, right? And again, so, programming language is, does not become popular because of its syntax. And with apologies to the brilliant Guido van Rossum, everybody knows who he is. That's the inventor of Python, right? And Python sickness is not exactly the thing of beauty. In fact, you can see that it started as a scripting language that had no classes, then classes appeared and so forth. And so some things like properties appeared later. So basically, the more advanced the feature, the more convoluted usually is the way that you set it up in Python. Like look at properties, for example, right? Which in languages like C#, they're they're native, right? Well, good thing in Java they don't exist, right? And you have to use additional bytecode editors to do that. So Python is not exactly the amazing syntax language in terms of a syntax. So the reason it became so popular is because it has a huge number of high quality packages which all work together. And having essentially what's an app store, right? So a package repository is as important as apps for the mobile OS, right? So, iOS and Android have great app stores. Anyone remembers Windows Phone, right? Great operating system, but no apps, right? And that's why it didn't take off. So the key strength of Python, that's why, I believe Python became so dominant, is that packages work very well together out of the box and continue to do so after the upgrades, right? So you keep upgrading packages and your code does not break. Unlike in C++, where to start out, you get a lot of compilation errors or issues that you normally have to fight through. With upgrades, a new version of C++ comes out, sometimes the code does not compile. So C++ is a powerful language. It's my first language I learned. It's amazing. Don't get me wrong. But, there is a reason why Python became so dominant, even though it's much slower, of course, and so forth. And one of these reasons, not the only one, but one of the reasons is that packages, there are so many packages and they work so well together. All right, so now, again, so there's a question of, okay, so there are a few more questions again, so I will answer them later on because I really need to continue because we're running a bit late. All right, so PyP, Python package index is the PyP.org, is a package repository and pip package manager. The package manager makes sure packages versions work well together. The default package manager distributed, or package installer rather, distributed with recent Python releases is pip, and it works with PyP. That's where it gets the libraries by default. But you can also configure it to pull packages from private package repositories such as Artifactory. Again, I should just say, I was surprised by this line of questioning here, but I think that with what's going on with software marketing these days, I think everybody has a reason to be suspicious. So no, we're not getting any advertising funding here from Artifactory either. It's just one of the commercial packages out there that you can install. So you have your own package repository, but we're not being paid for them by them. And there are competitors as well, and including commercial and open source. All right, so PyP, right, or pip, uses the list, or the pip, right, installer, uses the list of third-party packages and the version stored in requirements.txt. And that's a file that tools like PyCharm expect to find, and pip uses to get the packages from whatever repository or series of repositories, like configure multiple repositories and looks in order. For example, open source first and then commercial or vice versa, or internal, sorry, first internal usually, and then open source, right? So pip is a tool that gets packages from package repository or multiple repositories, and you can specify which packages your project needs using requirements.txt, which is a good way to do it, and also is required for many of the continuous integration servers, which is basically a servers that continuously build your code and make sure it works. Right, so hands-on session. So setting up PyCharm and virtual environment, setting up venv for the project, installing packages from requirements into venv, and setting up test execution. Okay, so let me now switch to PyCharm, right, which I already previously pointed to a source repository. Right, so so let's first of all, let me go here and look at settings, right? So first of all, the way that you open or create the PyCharm project after you have the checkout from Git is simply by opening, right? So unlike things like Visual Studio, you don't need with PyCharm to create any project file, right? So with environments which like Visual Studio, for example, which is a great development environment, but with that environment, you have to create the project file first in most cases, right? And then well, in case of C++, you need to create a make file, right? So for Python, you simply open the folder. That's the easiest way, right? So I'm going to open the folder. That's my folder. It's actually already open, so I'm going to cancel out of here, right? And the second thing is that you need to use the package structure and sorry, 1 second. You need to use you need to set up the package structure and pattern interpreter. So let me just take this one by one. 1 second. Just trying to move this thing out of the way. Which is blocking the view for me, but not for you. Right, okay, so first of all, we just talk about virtual environment, right? So a virtual environment here is based, first of all, it's located, it's a bit faint here, but you can see that it's located in this folder called venv, which is the subfolder of our code folder, or rather of the source repository, right? So there's a source, and you can put the source in root. I normally recommend creating a src package because then you can put like doc package next to it and other things outside the src package. And PyCharm would have to look here, right? And the venv folder is here, and it's created by PyCharm. When you do this, let me just cancel out of that, right? So if I go and say add, it can use existing environment or new environment, and you select here virtual11 conda, right? So you only need to worry about the first two because I've not. There was actually ppenv, question. I don't know. I mean, maybe I shouldn't be so. Maybe I shouldn't be so. I don't know, categorical, right? So I know I've seen more virtual environment in Conda. Yeah, so yeah, there are all these others. PyCharm is your friend, right? It'll help you create it. But let me just talk about virtual environment because this is not a 3-semester course, right? Or 6 semester. Sorry, this is not a year-long course, right? This is a full lecture course, so we need to keep moving. So new environment, right? First of all, specify where to place it, and you can place it anywhere, but usually the most convenient thing is to put it together with source, because if you delete the source, you delete the virtual environment, so you don't have to delete it separately. You need to use the base interpreter. And if you just keep using Python, you will install your packages into the core root, and you will not be able to then test with different versions of them. I normally leave this unchecked. As I mentioned, I'm using 3.9 because it's usually a good idea to stay one version behind the latest version of Python, right? And if I clicked OK here, well, the reason is complaining. The reason it's not letting me click OK is because I already created it. So you see, it says environment location directory is not empty. If it was empty, I would click OK, and it will create it with empty set of packages, right? I already did that, so I'm going to cancel out of here. And here it shows me the list of packages installed. In the list of packages that were installed, this list came from this requirements.txt file. And requirements.txt file is the file where you specify package name in the version. And usually the best way is to look at the version you just installed and say more or equal than this one, right? So it doesn't go back. Sometimes, like for NumPy, for example, there is a bug in the latest version that takes time to fix and it breaks your code. In this case, you say equal, right? Instead of more than equal, you put equal. And that, if you're lucky, right, will downgrade all of the other packages such that they are compatible with this package. Because the strength of the Python package manager is that it keeps track, and it requires very careful testing, which packages work with version, which with what other package versions. And if you're going to post your code into PyPy, right? So that's here, right? So if basically if you're famous and you have an open source project, or even if you're not famous, you just post it here, right? You can search and it will come up with projects, right? For example, there are thousands of data utilities here, right? So if you want your code to be here, if you want your code here to have good reputation, you need to very carefully test which versions of third-party packages it worked with. Because if it's not properly tested, then your code will break, or it will break some other code, right? So in other words, you need to test, when basically Python package manager figures out which version of one package works with which version of another package, that's what keeps the whole ecosystem healthy. And that's why when you say requirements and new version of package comes out, it just upgrades it for you. And you don't have to worry normally about, you read a test, of course, but most of the time it just tests pass. So it's extremely important that you do your part. So if you post your project here or to your internal, if you work for enterprise software development firm, or for basically part of enterprise software development organization, it's critical that you test your package against which versions of the other packages work, and then you specify in the requirements file which versions they work with. Like it may be less or equal. So in this requirements file, it may be less or equal some version. If at some point the latest release of that package broke something for you, it may be exact version if you don't want a previous version, but you want this exact. And the rule is that more flexible it is, the less likely it is that the package manager will throw their hands up and just say, hey, I cannot find a combination of packages that satisfies the requirement, because most packages, they want the later versions of everything. So try to be as open, like for example, don't say equal, say less than equal, if, or less, or, there's, you can specify like the range. And that's how you make your package safe to use for others. Any questions about this before we continue? Okay, right. So now finally, we're running kind of late here. So I think that what we'll do is, I think that this actually, yes, exactly. So as I thought, this is the last slide. So this is what we'll do. I was hopeful that we will move faster, and we'll be able to get through the project configuration part today, which is actually relatively short section. However, they answered a lot of questions. I hope to answer more. So what we'll do is that, given that we scheduled only 1 hour, we will do project configuration in the next day lecture, right? So I'll repost the slides where they belong to day 2. And I'm just going to go through setting up test execution, and after that, I will answer the questions. We'll break for the day. All right, so test, right? And we will talk. There's a bit of a chicken and egg problem here, which is that I cannot talk about configuration without the package structure, but also the package structure requires having configuration so I can actually play with it. So I will not talk about the folders and why they are these folders right now. However, I will talk about this test folder, which is here. Okay, so there are there are several leading, that actually probably should be next empty line here, right? So there are several leading test frameworks for Python. And again, so most of them are open source. I don't want to be categorical saying, well, use this one or use this tool. Nothing else makes sense. But the 2 popular ones is the granddaddy, right? So, it's basically unit test, right? And PyTest. And we will actually talk a bit later, right? So there's this called debugging running section here. So here, I'm pointing with the mouse. I hope you can see that. So I'm sharing that part of the screen as well, right?
Mm-hmm.
Yeah. So in this debugging running, we'll talk about unit test, PyTest, and so forth, right? So here, I'm just simply, we'll show you how to run it in PyCharm, right? So that part has to do with simply how to use PyCharm. So I already showed Git, right? If you want to run something, like for example, if I want to run a test, right? Address class test, and we'll talk about address a bit later, right? I can do it from here, or I can do it from here. Okay, so this shows to-dos. I don't have any. Shows problems. Well, that's MyPy. We'll talk about it later. This is the terminal, right? So that's where you do pip install. I already did it, but the key thing is that unless it says venv here, scream in horror and close it, right? Because basically, if it says venv, you are installing or doing something with the virtual environment. If it does not say venv, you're likely doing it with the core installer, and sometimes venv is not picked up by PyCharm, and it will try to install packages into your core Python. You'll have to reinstall it. So I'm going to go pip install -r requirements txt, and it will tell me, as I hope, that everything is already installed, right? If it wasn't, it would be installing right now. Okay, so now next thing is Python packages, right? So it just tells me which versions of packages I have. So we already went through that in the setup. So MyPy is a linter. We're not yet ready to talk about the linters, and we will soon. This is a Python console, and finally we need the test, right? So in order to run tests, one way to run an individual test, you can simply run it from a command line. If you configured your test with this little main at the end, right? So I can run it like that, and that will open a new tab called tests. Actually, sorry, no, it will take over the tab called run. I'm sorry. Right, so you see that it executed the test, right? Or I can right click here and it will find and run all of the tests in here. Okay, so having automated tests is absolutely critical. In the next section, next day, right, next lecture on Wednesday, we'll talk about, first of all, packages and namespaces. We'll talk about why this particular folder structure is appropriate for an enterprise project, what alternatives are, and what is the difference between the typical kind of compact package, single purpose package, like open source package, or commercial, right? But the package that is a small package with a single purpose, and why it requires one folder structure, and why a large scale project with many modules requires a different structure. And we'll talk about things which are called implicit namespace packages, which is a way to have different roots and then put the code together in Python, which normally you cannot do without it. So it's actually a relatively new feature of Python. We'll talk about naming and style conventions, and about how to keep them, how to easily meet them using automated code formatters, style checkers, linters, and so forth, and the role of linters. And we'll talk about debugging and running the code. We will talk about traditional unit test frameworks, and also things like system tests, how to set up an isolated system test with a database if you don't want the test to be affected by the state of the database. We'll talk about these things, as well as about an approach called approval tests. So that's a kind of, I will say, moderately popular, but not hugely popular open source library. But here I'm talking about not just the library, but the concept, right? So you can use the library, actually I like it, but you can also implement approval test concept without the library. An approval test is that instead of checking in your body of your test if the result is correct, like it's done here, right? So like, for example, here it says, for example, that length of this attribute is 0, right? So I'm checking that instead of doing this assert. It will do a different type of assert, which is a preview of that thing, where it will basically, you will save your result once, and then next time you're simply checking that is the same. So basically, it's a way to do regression, or more precisely non-regression, because you don't want regression, right? So non-regression testing. All right, so with that, it's 1 hour. So we're going to wrap, and let me just go now to the chat and answer the question. So video will be available. Before I go to questions, again, for those who don't want to wait and or has to go somewhere else and needs to disconnect, the next lecture is on Wednesday, 2 days from now, same time of day. All right, so a few questions. Okay, let me see which ones already answered. Why PyCharm and not VS Code? I think VS Code is great. I mean, I just like PyCharm more. I think that one thing with PyCharm is that it has a pretty amazing linter that's built in. That's not available in VS Code. Also, VS Code has a very strange feature, and again, with apologies to VS Code developers, maybe I just don't know how to use it properly. But basically, what happens is that if your tests have an error and your test parser, right, your PyCharm, sorry, your PyTest or your unit test module parses the test folder and encounters an error, in VS Code, it just hides the test that it didn't like. And you basically may think that your all tests are passing. In other words, if your tests break, not because they give the wrong result and they fail, assert fails, but simply there's an interpreter error, like some import package is missing or syntax error. At least the default behavior in VS Code used to be, last time I was looking at that, which is they just hide the test, right? It's just not visible to VS Code. VS Code kind of does too much through Python itself. And tries to be like VS Code tries to basically be just very thin tool which does everything through Python, whereas PyCharm does more things directly, right? So actually, that creates some positive, I think, difference there in favor of PyCharm, which I like, and I think it's more popular. But the VS Code, I think, is a great environment, right? It's also more configurable. And I did use it before as well. All right, what I think about pipenv, I cannot really say much. I didn't use it, so I don't want to volunteer that. I'll answer that question. Let me just look it up, and maybe I'll comment something in the next lecture. What's your opinion about the location of the development environment in Docker? Okay, so likewise, basically using Docker to develop, if that's what the question is about, is a whole separate topic. So I don't want to, overrun by more than 5 minutes. And we're at 1:05 right now, so I think that this probably is a bit outside the scope of the course. But please send maybe if you want to just contact us and just ask, provide your contact, maybe we can answer privately. If that's interesting discussion. All right, so with that, it's already 1:05 in New York, 1:05 in New York, right? So we've been doing this for 1 hour. So, thank you for joining the course today. I hope you found it useful. Next time, next day, we'll start from project configuration and spend the next 15 minutes or so doing that. And then after that, we'll go to a very interesting new and Python specific material.